All right. We have the given, which is 8x, y, and -1, are the first four terms of a quadratic number pattern, where 2k minus 4, k minus 3, and k over 2 minus 1 are the first three terms of the first difference of the quadratic. The question is solve for x, y, and k, where 8 is t1, x is t2, y is t3, and -1 is t4, is the fourth term of the quadratic number pattern. All right. From the equation, from what we can see here, where we can start it is by just doing the most basic, where we say t2 minus t1, which is x, minus 8 is equals to 2k minus 4. It's given. It's there in front of us. That the difference between t2, which is x, and t1 should be 2k minus 4, is this one. We're going to label this as our first equation, right? We can rearrange it where we have x only on one side. We rearrange it, it becomes 2k. It becomes x is equals to 2k. This one jumps to this side. -4 plus 8 becomes plus 4. Then we say this is our real first equation, right? This is our real first equation. And then we have another situation where we say t3 minus t2 should be equals to this given. t3 being y minus x is equal to k minus 3. Again, let's proceed to make y the subject of this one. Therefore, what we are left with is y is equals to k minus 3 rather, plus x. Right. This is going to be our equation number 2. And then we say we have again t4 minus t3, which is -1 minus y should be equals to k over 2 minus 1 is given. We rearrange it again as we've been doing. It leaves us with, now let's make k the subject of the formula. We first multiply everything by 2, which is minus 2 minus 2y is equals to k minus 2. Therefore, k is equals to minus 2 minus 2y plus 2, because this 2 comes this side. Therefore, k is equals to minus 2y. This and this, they cancel. This becomes our third equation. Having these equations, we then proceed to say, let's find the equation. Let's find the value for x, y, and k. Having these two equations. This being our first equation, this being our second equation, and this being our third equation. We begin this by first saying, let's sub equation 1 into equation 2. Right, therefore equation 2 is y is equals to k minus 3 plus x, but x is equals to all of this, right, which is 2k plus 4. This is x. Therefore y is equals to k minus 3 plus 2k plus 4. Y is equals to this and this is 3k, this and this plus 1. All right. We can proceed to say this is our equation number 4. Okay. We say this here is equation number 3. We have it. Sub equation number 3 into equation number 4. What we have is this here. All right. So if y is equals to 3, k is equals to -2y bracket plus 1. Therefore, y is equals to -6y plus 1. This one goes that side. It becomes 7y is equals to 1. Therefore, y is equals to 1 over 7. But again, since we have equation number 3, which is this one, which states that k is equals to negative 2y, therefore k is going to be equals to negative 2, 1 over 7. Then k is equals to 2 over 7, which is negative. This is that. But then, what is x? Remember, x is equals to 2k plus 4. Alright? X is equals to 2k plus 4. Okay, x is going to be equals to 2. K is negative 2 over 7, bracket, plus 4 is equals to 4 over 7, which is a negative, is equals to x plus 4. X is equals to, you add this, you have minus 4. This times 7 is 28, all divided by 7. X is equals to 24 over 7. Therefore, we can proceed to say k is equals to negative 2 over 7. X is equals to 24 over 7. And then y is equals to 1 over 7. Maybe I made a mistake somewhere, but this is the process, the method in which you're going to use to find x, y, and z. Maybe I made a mistake somewhere because it's a bit too long, but this is the method. The method is this one. As far as I'm concerned, I didn't make any mistakes, so therefore these are my answers. X, Y, and Z. X, Y, and K rather.